Today we're going to be talking about quadratic inequalities. And so you guys are already familiar with the symbols of the quadratic of inequalities. This means greater than, this means greater than or equal to, this means less than, and this means less than or equal to. And so what I did include though was some of the vocabulary. So this will come in handy for your word problems. So on your word problems, this would be a good guide to refer to if it says, at least you know which symbol that you're going to be using to set up your word problem. So let's jump right in. We are solving inequalities. So we're going to solve these inequalities similar to how we would solve a quadratic equation. So if I just pretend for a moment that this is an equal sign and asked you to solve that, you would start by just factoring what they have in common to the front. So notice they have a 2 in common and they have an x in common. So now what I'm going to do is I'm going to write what's left. So out of my 2x squared, if I took a 2x out, I have only an x left. Similarly, if I have 14x and I took 2x out, I have 7 left. And so here's what your equation is going to look like now that you have factored it. So what I'm going to do is I'm going to take each one and I'm going to set them equal to 0. So 2x equals 0. X minus 7 equals 0. I know that this is an inequality and this is an equal sign, but what I'm basically doing is I'm trying to figure out testing values. So it doesn't really matter what symbol you're going to use. It's like you're solving for x. So if I solve this for x, I've got x equals 0. And then over here, I'm going to add 7, and I will have x equals 7. So this is not my solution. If this was an equal sign, then yes, these would be my two solutions. But because this is in an inequality, I have to test it. I have to test intervals. So basically what these gave me was this gave me my testing intervals. So what I've got to do now is see, I've set it up on a number line and I'm going to test on this side of 0. I'm going to test in the middle and then I'm going to test on this side of 7. And I'm going to see, do they give me true or false statements? So what you're going to do is you're going to pick what I call a dummy number to represent all of the values that are less than 0. So like -1 would be a great one. Anything that is in between 0 and 7, so like the number 2. And then anything above 7, so like 10. Now you can pick whatever numbers you want. Those are not like set in stone. You don't have to use those numbers. Those are just the numbers that I chose. So as long as it falls within the interval, you can use whatever you want. You can pick whatever you want. So what I'm going to do now is I'm going to set them up. I'm going to test these intervals. So what you do is you take your original inequality and you plug in your testing values. And you see if that gives you a true or a false statement. So here, if I calculate this out, 2 times -1 squared minus 14 minus 1, and you get 16 is less than 0. Is that a true or a false statement? That is a false statement, so what I'm going to do is I'm going to put an X. And I'm going to come up here and I'm going to X out that interval. That is not going to be part of our answer. Okay, so now I'm going to plug in 2. 2 times 2 squared minus 14 times 2 is less than 0. So when you plug that in, we get negative 20 is less than 0. Is that a true or false statement? That's going to be a true statement. So what I'm going to do is I'm going to come over here and put a check mark. That is going to be part of our answer. Last interval, 2 times 10 squared minus 14 times 10 is less than 0. That is going to give me 60 is less than 0. Is that a true or a false statement? That's a false statement. So I'm going to come up here and I'm going to cross that interval out. Now, anything that has an X on it is not part of our final solution. Anything that has a check on it is going to be our final solution. Now, we're going to go ahead and write this in interval notation. So what that means is I'm going to write my solution. Anything in between 0 and 7 is going to work. Now, notice you have to pay very careful attention when we write things in interval notation, because if we have the symbol less than, then we have to use parentheses. Let's come up here and let's go ahead and indicate what we would use for each symbol. So here we would use parentheses. Here we would use brackets because we want to include, because of that equal to symbol. So parentheses and brackets. So when you are working through your problems, make sure that you check before you write your solution in interval notation that we are writing it either with parentheses or brackets according to the correct symbol. Okay, so let's do another example. Again, I'm going to start by factoring what I can to the front. So I can actually take out a 4x. And that's going to leave me with x minus 9 is greater than or equal to 0. So what I'm going to do is I'm going to set each of these equal to 0 and get my testing values. So 4x equals 0, x minus 9 equals 0. Divide by 4, I get x equals 0. That is one testing value. And then my other testing value is 9. So I'm going to come up here and I'm going to draw it on a number line. So 0 and 9. And now I'm going to pick my values, my testing values. So anything less than 0, I'm going to use negative 1 again. Anything between 0 and 1, I can use the number 1. And anything above 9, so 10. So those are going to be my testing values. I am going to use those three values and plug them into the original inequality and see if it gives me true or false statements. So 4 times negative 1 squared minus 36 times negative 1 is greater than or equal to 0. That gives me 40. Now, is 40 greater than or equal to 0? Is that a true or false statement? That's a true statement. So I'm going to come over here and put a check mark. And then I'm going to move on to the next interval. 4 times 1 squared minus 36 times 1 is greater than or equal to 0. So 4 minus 36 gives me negative 32 is greater than or equal to 0. Is that a true or a false statement? That's a false statement, so I'm going to come over here and cross the interval off. Now I'm going to test 10. 4 times 10 squared minus 36 times 10. That's going to give me 40. Is 40 greater than or equal to 0? That's a true statement. So notice I have two intervals that give me true statements here. I'm going to write that as my solution. Now make sure you pay attention to your symbol. We have greater than or equal to, which means I'm going to be using brackets when I write my solutions. So my solution is going to be negative infinity up to 0, bracket. And then in order to connect the two, I am going to write a u and then write 9 to positive infinity. So we have all the values negative infinity up to 0. And then we start at 9 again and go to infinity. That's how you would write your solution in interval notation. Okay, so here we've got another one. I am going to, first off, it has to be, it's almost like an equation. It has to be set equal to 0. So we need everything on one side. So first thing I'm going to do is I'm going to move over the 20 by subtracting 20. So this would be my new inequality. And this is the one that I'm going to use to plug in my values to see if it gives me true or false statements. Now, on this, if you look here, I can actually factor out a -2. So that's exactly what I'm going to do. And that's going to give me x squared minus 3x plus 10 is greater than 0. So what I'm going to do is I'm going to treat this like, again, like if I'm solving an equation. So first thing I'm going to do is check and see, does it factor? Because if it will factor, then that's probably the easiest route to go to get your intervals. So I'm going to look here and see, are there factors of 10 that will add to -3? What times what will gives me 10 that adds to -3? And there's not anything. This will not factor. And so from here, I'm going to say, okay, it won't factor, so therefore I'm going to plug it into the quadratic formula now. So I'm going to identify A is 1, B is -3, and C is 10. And I'm going to go ahead and plug it into the quadratic formula. So minus B, so minus a -3 is a +3, plus or minus the square root of B squared minus 4 times A times C all over 2A. Now, when I do this, I get underneath, when you do -3 squared minus 4 times 1 times 10, you get -31. Now, this is an imaginary, which tells me solution-wise, there's not any testing points. So, this tells me at this point I have two options. If there's not any testing points, then what I'm going to do is draw my number line, and I'm just going to pick a number. So like 0 is always a good choice. And I'm going to test 0, because what happens is when there's no testing intervals, you have two choices. It's going to be either no solution or it's going to be all solutions, all real numbers. So what we have to do is we have to pick a number and plug it in and see, does it give me a true statement? Because if it gives me a true statement, then it's going to be all real numbers. If it gives me a false statement, then it's going to be no solution. So if I pick 0 and I plug in 0, and I'm going to plug it in to this equation right here, or this inequality right here. So -2 times 0 squared plus 6 times 0 minus 20 is greater than 0. And what this does is this gives me -20 is greater than 0. Now, is that a true or a false statement? That's going to be a false statement. So that means there's going to be no solutions to this problem. There's no interval, no number, nothing that we could plug in that will give me a true statement ever. Okay, so now moving on to D. What I'm going to do to solve this one, when you see them in this form, where you have like a x minus 2 squared, I'm going to show you how we would solve that a different way using the square root property. So what I'm going to do is I'm going to go ahead and just set that equal to 0 and pretend like I'm solving a quadratic equation. So first thing I would do to solve for x would be to move the 1 over. So I'm going to subtract 1. So I get 1/4 x minus 2 squared equals negative 1. And now I'm going to divide by 1/4 to cancel that out. So divide by 1/4. And that's going to give me x minus 2 squared equals negative 4. And then the next step I'm going to take would be to solve for x, would be to undo the square. So I'm going to square root. Now again, we just encountered the same thing that we've encountered on part C. Can you take the square root of a negative? You can, it's just going to give you an imaginary, which tells me there's no testing values. That doesn't mean that there's no solution. That means there's no testing values. So again, I'm going to just draw a number line and pick a random number. I mean, you could pick whatever number you want, from negative infinity to positive infinity. We just want to test one point just to make sure. This is going to either give me no solution or it's going to give me all solutions. Now remember, when I told you at the beginning of class, we actually need to switch this from a less than or equal to a greater than or equal to. Okay, so when I plug in 1/4 times 0 minus 2 squared plus 1, I get 2. 2 is greater than or equal to 0. That is a true statement, which means that tells me any single number on the number line from negative infinity to positive infinity is going to give me a true statement. So it's the exact opposite as what we did on C, where we plugged it in and got a false statement. We have no solution. Here we plugged it in and got a true statement, so it's all solutions. Every real number, negative infinity to positive infinity. And that takes care of both opportunities when you have no testing value, but you have a no solution or all solution problems. Okay, so moving on to part E. First thing again, I want to move everything to one side. Now, my x square is already positive over here. I like to leave my x squares positive if I can. So what I'm going to do is I'm going to move the 8 over here. So I'm going to say x squared plus 7x minus 8. I just moved it to the other side. And again, I'm going to pretend like this is an equation, like if I'm solving, because I'm going to solve and get my 2 test points. So, can you factor this? I always start by seeing if it will factor. If it will factor, that's the easiest route to take to get your testing values. You can always use quadratic formula. Quadratic formula will always work. But I always see if I can factor it first, and then if I can't, or I'm having a hard time seeing what the factors would be, I go ahead and move on to the quadratic formula. Okay, so here I've got x and x, and I am breaking down the factors of 8 that subtract to 7. What times what gives me 8 that subtracts to 7? And that's going to be 8 and 1, positive 8 and minus 1. So if I set both of those equal to 0, and I solve, I'm going to get 2 test intervals, 2 test values, negative 8 and positive 1. So I'm going to come over here, I'm going to draw my number line, and I'm going to put negative 8. You always put them in, in order, least to greatest, and 1. And I'm going to, that means that I've got 3 different intervals that I need to test. So I'm going to come over here and I'm going to pick 3 different numbers. So like negative 10 would work here. 0, if you can use 0, always use 0. It makes it easier. And then 2. So those are the 3 values that I'm actually going to be plugging in. And I'm going to be using this one right here. So 0 is greater than negative 10 squared plus 7 times negative 10 minus 8. So when you plug all of that in, you get 0 is greater than 22. Is 0 greater than 22? It is not. Is not a true statement. I'm going to come over here and cross that interval off. He's not a part of my solution. So that now I'm going to plug in 0. 0 is greater than 0 squared plus 7 times 0 minus 8. So when you plug all of this in, you get is 0 greater than negative 8? Yes, that's a true statement. So my solutions, I know, are going to go from negative 8 to positive 1. I have one more interval to test, so I'm going to plug in 2. 2 squared plus 7 times 2 minus 8. And when I do that, I get 10. Is 0 greater than 10? No. So, again, your final answer, you go back and you look and see where are the true statements from negative 8 to positive 1. So if you write that in interval notation, again, make sure you take into account your sign. I'm going to be using parentheses, not brackets. So my solution is negative 8 to positive 1. That means that I can plug in any value between negative 8 and positive 1, and that will give me a true statement. All right, now we're going to do a couple of word problems. The function y equals negative x squared plus 20x models the profit y in dollars earned by a tour guide when X people sign up for a tour. How many people need to sign up for a tour in order for the profit to be at least $75? First off, when we're trying to set this up, I'm going to go ahead and look up here because it says at least $75. So I'm going to go ahead and go up to my guide of symbols and find where it says at least, so that will tell me the correct symbol that I need to use. Notice right here, at least. So that means that I'm going to use the greater than or equal to symbol. I want $75 or more. So when I'm setting that up, I'm going to use the greater than or equal to symbol. So first thing is, okay, I'm going to set up my equation. I'm going to come right here. X squared plus 20x is greater than or equal to $75. So this is my inequality setup. So in order to solve it, I'm going to go ahead and move everything to one side. Now, notice my x squared is negative over here. I don't like that. If I'm going to try to factor, I want this to be positive. So I'm going to go ahead and just move everything over here. The x squared and the 20x. You don't have to do that, but that's what I'm going to do because I like my x squared term to be positive. So this would be what it is if you move everything to the right side. And I'm first going to check and see, can I factor that? So break down the factors of 75 that add to 20. And that's going to give us 5 and 15. So I'm going to factor this, negative 5 and negative 15. Okay, so again, you're going to set that equal to 0, each one equal to 0, and solve and get your testing points. So 5 is going to be a testing point, and 15 is going to be a testing point. So if I'm going to test 5 and 15, I'm going to go and pick my values that I want to use for each. I'm going to have 3 intervals that I'm going to test. So I'm going to pick the number 0 for this, the number 10 for that, and the number 20 for that interval. And again, you're going to go ahead and plug them in. I'm going to plug them into this one right here that I have set equal to, or set greater than or equal to 0. So I'm going to plug in 0 is greater than or equal to 0 squared minus 20 times 0 plus 75. And that gives me 0 is greater than or equal to 75, which is a false statement. So now I'm going to go ahead and plug in 10. So 0 is greater than or equal to 10 squared minus 20 times 10 plus 75. And that gives me 0 is greater than or equal to negative 25. And that is a true statement. So last one is 20. So 0 is greater than or equal to 20 squared minus 20 times 20 plus 75. And that gives me 0 is greater than or equal to 75, which is a false statement. So my only solutions are between 5 people and 15 people. Can they make a profit of at least $75? Now let's answer part B. Part B says how many people need to sign up for a tour in order for the profit to be more than $100. So in setting this up, I'm going to do the same thing. I've got negative x squared plus 20x is greater than 100. So again, I'm going to do like what I did on the first inequality. I'm going to move both of these over here so that I wind up with a positive x squared. So moving everything to the right side, I've got 0 is greater than x squared minus 20x plus 100. I'm going to see if this will factor. What times what gives you 100 that adds to 20? And that is 10 and 10. So if because these are the same, I'm just going to set x minus 10 equal to 0 one time and that means I've only got one testing interval, and that is 10. So I'm going to pick a number on the left side of 10, 0, and I'm going to pick a number on the right side of 10, 20, and I'm going to plug those in and see if they give me true or false statements. Again, I'm going to plug it into this one. So 0 is greater than 0 squared minus 20 times 0 plus 100. And that gives me 0 is greater than 100. Is that a true or a false statement? It's a false statement. I'm going to plug in 20 now. 0 is greater than 20 squared minus 20 times 20, 20 times 20 plus 100. Is that a true or a false statement? That's going to give me 0 is greater than 100 again. So we've got another false statement. What happens when you have no interval that works? You have no solution. But let's look at the context of the problem, because we're not just going to write no solution. Look and see. It says how many people need to sign up for a tour in order for the profit to be more than $100. Well, what we're going to say here is that the profit never exceeds $100. Will never exceed $100. And that's how we'll write no solution as far as in the context of this problem. Moving on, we've got one more word problem. We're going to do the same thing. So we're going to set up our equations. or inequalities. And we're going to use our testing intervals, and we're going to see what yields true and false statements. So, during the opening of a video game, the sun follows a path modeled by the function y equals negative x squared plus 6x, where y is the height of the sun above the horizon in centimeters and x is the time in minutes. For which times is the sun more than 8 centimeters above the horizon? So if it wants times more than 8 centimeters, that means greater than. So what I'm going to do is I'm going to write my equation. Negative x squared plus 6x is greater than 8 centimeters. So they want to know when is it more than 8 centimeters above the horizon. So again, I'm going to move everything to one side. And because this is negative, I'm going to move everything to the right side so that I can make that a positive. Okay, so 0 is greater than x squared minus 6x plus 8. See if that will factor. What times what gives you 8 that adds to 6? And so we have negative 4 and negative 2. So go ahead and take each of those and set them equal to 0 and get your test interval. So I've got a test point of 4 and I've got a test point of 2. So on a number line, if I set that up, I've got 2 and 4. So I am going to have 3 testing intervals. So I'm going to pick numbers in each of those intervals to test. So 0, 3, 5. And go ahead and plug those in. And I'm going to plug it into this one. Is 0 greater than 0 squared minus 6 times 0 plus 8? And I get 0 greater than 8. Is that a true or false statement? So false statement, so that is not going to be in our solution. And then I'm going to plug in 3. So 3 squared minus 6 times 3 plus 8. That is going to give me 0 is greater than negative 1. Now, is that a true or a false statement? It's a true statement. So I'm going to put my check and do my last test. 0 is greater than 5 squared minus 6 times 5 plus 8. And that gives me 0 is greater than 3, which is a false statement. So, for what times is the sun more than 8 centimeters above the horizon? Well, we know our only interval that worked was between 2 and 4. So think about the context of the problem. So I know between 2 and 4 minutes that the sun is going to be more than 8 centimeters above the horizon. So make sure that on your word problems that you are writing your answers in the context of the problem, because this, even though it's correct, is not telling me anything about the problem. So make sure that you write your solutions on the word problems in the context of the problem. And that takes care of quadratic inequalities.